This is an example of how to solve a matrix equation using inverses. Several steps here, so let's try to put them all in order. The first thing that we want to do is we want to solve for x. So if we want to solve for x, we have to undo this particular matrix. To undo a matrix, you want to multiply it times its inverse. So we have several steps that we want to do here. We want to multiply this by its inverse. In order to find its inverse, the first thing that we'll do is find its determinant. So I'm going to find the determinant. So I have to find the determinant of this particular matrix right here. So I'm going to pull it down, and I have 12, 7, 5, 3. So to find this determinant, I'm going to multiply 12 times 3 and get 36. 7 times 5 minus 35. So that determinant is equal to 1. From this determinant, I'm going to use that to find the inverse of that particular matrix. To find the inverse here, the inverse is 1 over the determinant, and this determinant is 1 right here. There's that determinant, 1 over 1, which is just equal to 1. And then we're going to swap A and D, change B and C. I'm still staying with this particular matrix. So I'm going to swap 12 and 3, so that's going to be 3 and 12. And I'm going to change the signs of 7 and 5. So that becomes negative 7 and negative 5. And of course, when you multiply that times 1, it just stays 3, negative 7, negative 5, 12. So this is my inverse right here. So here's my inverse. Now, the key, or something that you have to remember, is that when you multiply times an inverse, you want to multiply on the left. So I want to stay on the left of the matrix. Well, if I'm multiplying on the left of this matrix here times this one, what I do to one side, I must also do to the other. So I'm going to multiply on the left to this particular matrix as well. So I'm going to just rewrite it. I'm going to change color to show you my new step. So I take my inverse, 3, negative 7, negative 5, 12, and I multiply that times 12, 7, 5, 3, x. Then again on the left, 3, negative 7, negative 5, 12, and I'm multiplying over here times this matrix here, 2, negative 1, 3, 2. So I've multiplied it. Here's the key. I've multiplied that inverse on the left. Here's my inverse of each side of the equal sign to both matrices on the left and the right. Now, what you're going to find that's unique about these two matrices right here, they are going to be inverses of each other, because that's what I found the inverse of. Since they're inverses of each other, they should give me the identity matrix. So again, when I'm multiplying, I'm looking at row by column. And even here, when I multiply, I'm looking at row by column. So now I'm going to multiply these together. So this is a 2 by 2 times a 2 by 2. So I have 3 times 12 is 36. Negative 7 times 5 is negative 35. Add those together and you get 1. So now I'm going to this row and this column. 3 times 7 is 21. Negative 7 times 3 is negative 21. Added together gives you 0. Second row. Negative 5 times 12 is negative 60. Positive 12 times 5 is positive 60. Added together gives you 0. Then this row, last column. Negative 5 times 7 is negative 35. 12 times 3 is 36. Added together gives you 1. Times x equals. Then I'm going to multiply these two over here. 3 times 2 is 6. Negative 7 times 3 is negative 21. 6 plus negative 21 is negative 15. First row, second column. 3 times negative 1 is negative 3. Negative 7 times 2 is negative 14. negative 3, negative 14, negative 17. Second row, negative 5 times 2 is negative 10, 12 times 3 is 36, negative 10, positive 36 is 26. Second row, last column. Negative 5 times negative 1 is 5, 12 times 2 is 24, 5 plus 24 is 29. Now, here's what we have. This particular matrix right here is called the identity matrix. Sometimes it's written like this, I sub 2 because it's a 2 by 2. If it were a 3 by 3, it would be I sub 3. But the identity matrix multiplied times any other matrix is simply that matrix. So when I write my final answer, this is just x. This identity times x is just going to be x. It's kind of like multiplying times 1. Then my final answer is negative 15, negative 17, 26, and 29. So there's my final answer here. If I want to check this, if you want to check it, you would simply go back, let me pick something I haven't used, to check it, and I'm going to write it real small, but you can go back if you need to. I'm going to go back to my problem right here, and it says 12, 7, 5, 3. If I multiply that times the answer that I'm assuming x is, negative 15, negative 17, 26, 29, if I multiply those two together, it's going to equal that matrix that it says it equals in the problem. It should equal to 2, negative 1, 3, 2. So if you have time after you take a test or something like that, you want to check your problems. So it's a very full page for one problem. That is how to solve an equation using matrices and inverse matrices.